Today's lesson is on operations with radical expressions. Specifically, we're going to focus on multiplying and dividing. So here's just kind of a real quick overview of what we're going to learn. So properties of multiplying and dividing radicals. The product property of radicals states that if you are multiplying two roots, they have to be the same root here. So the nth root of A times the nth root of B is equal to the nth root of A times B. In other words, two roots, they're both the same root. You can just multiply the numbers together. So like square root of 2 times the square root of 3 is the square root of 2 times 3, which is 6. Okay, so 3 examples. So I have the square root of 8 times the square root of 12. So that tells me that I can do 8 times 12 and keep it under the square root. 8 times 12 is 96. But we're not done right there. You always have to simplify your radicals. So let's break 96 up into factors where one of them is a perfect square. Well, 96 can be broken up into 16 times 6. So then it's like I can do the product property backwards. The square root of 16 times the square root of 6. Square root of 16 is 4. Square root of 6 left over. The next example, 3 times the square root of 2 times 2 square root of 6. All right, so in between the coefficients and the radicals, it really just is multiplication. So if we can rearrange this, think of it as your front numbers, 3 times 2, and then square root of 2 times the square root of 6. So 3 times 2 is 6. And then the square root of 2 times 6 is 12. And then we have to simplify. So I have 6 times the square root of, let's break up 12. I can break that up into, let's see, factors where one of them's a perfect square, 4 times 3. So 6 times the square root of 4 times the square root of 3. Square root of 4 is 2. 6 times 2, square root of 3. 6 times 2 is 12 square root of 3. All right, the last example, we're going to add in some variables. So 3 square root of 3x to the third, lots of 3's, times the square root of 12x to the fourth. All right, so we only have the one coefficient, is that 3. So the 3 will just follow down, and then 2 radicals, so I can multiply them. 3 times 12 is 36, and then x to the third times x to the fourth. Remember, property of exponent says we would add those, so that becomes x to the 7th. All right, so let's think about this. I don't need to break 36 up because 36 is already a perfect square. So I've got 3 times the square root of 36, but I do have to break up my x to the 7th. So remember, you just go one less, x to the 6th and another x. All right, so 3 times the square root of 36 is 6. The square root of x to the 6th, cut it in half, so it's x to the third with the square root of x left over. 3 times 6, 18, x to the third times the square root of x. All right, so now we're looking at the quotient property of radicals, so we're dividing. So the quotient property of radicals states that if you have the nth root of a quotient, or like of a fraction, what that means is you can take the nth root of A, and then the nth root of B. So in these questions, sometimes we'll start with something like this and we'll go here, or maybe we'll start actually over here and we'll go here. You kind of just have to decide which way fits the problem that's given to you. But in real simple terms, if you have the square root of 25 over 64, you could think of that as the square root of 25 over the square root of 64, or 5 over 8. All right, example number 1 is the square root of the fraction 72 over 196. So one thing you have to decide, sometimes you can simplify the fraction first, or sometimes it's better to just go ahead and square root both. So for this one, because 196 is a perfect square, I'm going to go ahead and take the square root of those separately. So the square root of 72 over the square root of 196. Well, the square root of 196 is 14. But the square root of 72, that's not a perfect square. But it can be simplified. So we need to think about, let's see, factors of 72. Let's break it apart where one of them is a perfect square. It's going to be 36 times 2. So the square root of 36 times the square root of 2 over 14. The square root of 36 is 6. So 6 square root of 2 over 14. Now that's almost done. You have to look to simplify. Now, when you're simplifying, you have to be careful. You can't simplify something under a root with something not under a root. But you can simplify two numbers that are both out of the root. So 6 over 14 can simplify to 3 over 7. So 3 square root of 2 over 7 is the final answer. All right, so our second example, the square root of 108 times x to the 5th over the square root of 4x. So this is a little bit different, where it's already split up. Let's think about this. 4, that's a perfect square, but x isn't. So what we can do is almost like use the property backwards. Here it's broken up, but let's write it as a square root of this fraction, 108 x to the 5th over 4x. Sometimes it's helpful to look at this fraction and simplify it first. Well, let's see, 108 divided by 4, 108 divided by 4 is 27. And x to the 5th over x to the 1st, we would subtract those exponents, becomes x to the 4th. Well, by simplifying, now I don't have a fraction anymore. So let's think about this. 27 is not a perfect square, but it can be broken up into 9 times 3. And then x to the 4th is a perfect square. So the square root of 9, square root of 3, and the square root of x to the 4th becomes 3 x squared with a leftover square root of 3. All right, third example, cube root of the fraction x to the 6th over 8. So same thing with cube roots. Let's see, it starts as a fraction. I can't simplify that, so can I take the cube root of the top and bottom separately? So I've got the cube root of x to the 6th. That's a perfect cube. And then the cube root of 8, which is also a perfect cube. Well, the top, 6 divided by 3, that turns into x squared. And the cube root of 8 is 2. So this one was short and sweet. Okay, the last part of this lesson is about rationalizing the denominator. This is just a rule, is that your final answer cannot have a square root in the denominator in the bottom of a fraction. So sometimes when you have that, we have to do an extra step to get rid of it. Okay, so here is an example. If I have 5 over the square root of 8, well, I don't want a square root in the denominator. So what I'm going to do is I'm going to multiply my fraction by a fraction that is equivalent to 1. When you multiply by 1, you're not actually changing the number. What we're going to do is just change the way our number looks, part of the simplifying process. So if I take the denominator, square root of 8 times the square root of 8. Now, square root of 8 divided by the square root of 8 is just 1. So I'm not going to change my number, I'm just kind of altering how it looks. And the reason I do this is because when you multiply straight across, so the top, I get 5 square root of 8. Well, the bottom, square root of 8 times the square root of 8 would be the square root of 64, which is just 8. Any square root times itself, it basically just cancels out the square root and leaves you with the number underneath. All right, so now we would be done, except the square root of 8 can be simplified. That could be simplified. So 5 times the square root of 4 times 2 all over 8. So that becomes 5 times the square root of 4 times the square root of 2 over 8. So 5 times the square root of 4 is 2, with the square root of 2 left over 8. 5 times 2 is 10. So 10 square root of 2 over 8. We're almost done. The numbers that are both outside of the square root can be simplified. 10 over 8 can be simplified to 5 over 4. So 5 square root of 2 over 4. All right, last example of this lesson. So I've got the square root of 7a to the 9th over b to the 5th. All right, well, I can't simplify this fraction, but I can take the square root of the top and the square root of the bottom. All right, so the square root of 7a to the 9th over the square root of b to the 5th. All right, well, I can't have a square root in my denominator, so I'm going to multiply. I'm going to rationalize the denominator. So I multiply by that fraction that equals 1. I take my denominator, multiply top and bottom by the denominator. Because the bottom, square root of b to the 5th times the square root of b to the 5th, the square root cancels, and I'm left with b to the 5th. In the numerator, I have 2 square roots, so you can just multiply together. So it becomes the square root of 7a to the 9th, b to the 5th. All right, but now the radical, the square root on top, I need to simplify. Well, the 7, I can't break that up into any factors, but I can break up the a and the b. This could be, so let's see, the square root, I've got 7 times, go 1 less, so a to the 8th times a, and then b to the 4th times b, all over b to the 5th. All right, so a to the 8th, b to the 4th, those are my perfect squares that will come out in front. And then the 7, a, and the b will all stay underneath the square root. So the square root of a to the 8th is a to the 4th. The square root of b to the 4th is b squared. And then I'm left with the square root of 7ab all over b to the 5th. And the very final step, anything, so numerator and denominator that's outside of the square root, we can simplify. So b squared on the top and b to the 5th on the bottom can simplify. So a to the 4th, the square root of 7ab, and there would be b to the 3rd left over on the bottom. So there is your full lesson on operations with radical expressions, multiplying and dividing. Good luck.